What if machine learning projects for beginners weren't just silly hello world examples, but real-life, professional pipelines that would actually impress people? Something original, useful, and simply explained. That's exactly what we will build today. We will download a real-life dataset from the city of New York, and we will use it to find out what makes people tip more in taxis. Is it the number of passengers? Is it the distance? Is it the time of day? And so on and so on. For this, we'll use one of the fastest machine learning algorithms, XGBoost, and we'll focus on reasoning like a data scientist, handling challenge after challenge logically. So whether you're a beginner or looking for a meaningful project to practice your skills, this video is perfect for you. So without any further ado, let's roll! Now, the first thing we need is a real-life dataset. In my case, the yellow taxi trip data from year 2023. We'll just download it from the city of New York, and it might take you a few minutes because this dataset is 38 million rows type of dataset. So if it sounds a bit too much, I actually made a smaller version of it with only 5 million rows, and you can of course download it from my GitHub. So if you're a beginner, start from the smaller one because it's a bit more manageable. Otherwise, go for the whole thing because that's what I'll be doing here. And here's the first problem that professionals are dealing with. If we try to load the full dataset with pandas, our runtime will crush. The file is just way too big, so how are we supposed to solve it? Well, what we usually do is just run the whole thing on GPU. If you don't have one at home, you can use it for free on Google Colab, so there's no need to find some creative alternatives. And it's mostly because you're barely touching your code when you switch to GPU. So let me quickly show you before we start coding, okay? Let me pull it out. So all it is just switching from pandas to cuDF pandas with this tiny line of code, and then down the road, when we train our XGBoost model, which is set the device to CUDA. And that's it. Everything else stays exactly the same. So things like chunking or splitting our data into a few files, they just don't make any sense. And with this in mind, let's set up our environment and let's start coding everything step by step, properly. If you are working in Google Colab and you've already set your runtime to GPU, there you go, then you don't need to install anything. All you need is to load the smaller dataset onto your Google Drive and then mount it like so. And that's it, you're good to go. But if you are working locally, just like myself, then we will open a WSL terminal. Not a Windows one, but either WSL or Linux. And in my case, I'll be working with my brand new NVIDIA RTX 5090, which is the top of the line of consumer GPUs. The step up from here is connecting to a data center. And this is probably what you'll be doing at work. So if you think that 32 gigabytes of VRAM is a lot, in enterprise professional settings, you'll probably be working with a bunch of B200s with 192 gigabytes each. So the consumer stuff, this is just a snack. Now, whenever you install modules for NVIDIA cards, we always go to the Rapids installation guide. And in here, we will scroll down, we will pick the nightly version, as well as our version of CUDA, in my case, CUDA 13. You can find it right over here. And then we will choose a specific package. Okay, in our case, we will keep cuDF as well as Jupyter Lab. Then we will go ahead and copy this command that was generated, and let me quickly paste it back in our terminal. Just make the text a bit larger. There you go. And let's paste it right over here. Now, in addition to the modules that we've already picked, we will also install XGBoost, which is our super fast machine learning module, as well as matplotlib, so we can visualize our data and plot it in a graph. Now, the last thing we'll do here, we will change the name of this environment. Almost there, okay, from Rapids 25.10 to XGBenv, okay, simple to remember, and let's give it a run. Then we will activate this environment with conda activate XGBenv. We will then navigate to the folder where we saved our dataset, in my case, NY taxi. And then finally, we will open our IDE with Jupyter Lab. So if our read CSV command was crashing earlier on CPU, the way to fix it is simply load an extension with %symbol load_ext, and the name of this extension is cuDF.pandas. Now, if we run this cell with Control-Enter, it will load our gigantic dataset almost immediately. So problem number 1 is officially solved. But when we look at our data, we can already see problem number 2. And it is a truckload of missing values. So we have both not applicable as well as none. And if we scroll a bit more, we can even see a whole bunch of nan. And I love nan when it comes to my bread, but not so much when it comes to my data. So let's go ahead and tackle it. For this, let's find out how many missing values we're dealing with here. So let's go ahead and select our dataset with data, and we will call the isNA method on it, followed by the sum method. And then this will display how many missing values we have in different columns. But here's the biggest challenge in handling missing values. We can't just get rid of them, because if we do so, it means that we are losing more than 1 million samples just because somebody forgot to enter something. So instead of dumping them, let's try to replace them first. So for example, if the airport fee is missing, then it probably means that there was no airport fee, or the airport fee was actually 0. And same goes for a congestion surcharge. So let's go ahead and copy one of these column names, and then we will select this column right below with data followed by airport fee, and we will then fill all the missing values with 0 by calling fill NA and passing it the number of 0. Then we will store the results back inside the original column. We will replace it completely, and we'll do the same for our congestion surcharge. We'll just copy this column name. We will replace airport fee with it, and boom. Hopefully my head doesn't block it. Great, so now if we run this new cell and we then rerun our previous cell, then our last 2 columns no longer have any missing values. Great, let's see what else is missing. Now, when it comes to passenger count, we can't really do the same, because if the passenger is missing and there are 0 passengers, then who's paying for the trip? So it is more likely that the driver forgot to enter it instead of just him driving around with a friendly ghost or delivering packages. We have UPS for that. So one common strategy is just figuring out the average, of the column, and then replacing the missing values with the average. So let's go ahead and copy this column name. And first, let's see how this average looks like. Let's say data in the column of passenger count dot mean, okay? And our average is 1.37. But here's another problem. There is no such thing as 1.37 passengers, okay? There's either 1 or 2. So it is up to you if you want to store the average or if you want to round it down to 1. In both cases, it is perfectly fine. So on my end, I'm just gonna store 1. So let's go ahead and copy one of these lines of code. Okay, let's replace congestion surcharge with a passenger count. And instead of filling it with 0, we will fill it with 1. Okay, then we can get rid of this cell underneath because we don't need it anymore. Now, if we rerun our newest cell and we then rerun our sum of missing values, we go up, and the only 2 columns we are left with are rate code ID and store and forward flag. But here's another problem, because in both cases, I have no idea what it means. It's probably something that the city of New York is aware of, but nobody else. So what are we doing here? Are we just getting rid of these columns? No. In the world of professional data science, we investigate first. So let's go back to our dataset. Let's scroll down and let's investigate these columns. So we see that rate code ID is the final rate code in effect at the end of the trip. What does it mean? Not sure. We will check it later. It's probably some kind of a label, internal label that the driver puts on the trip. And we also had, what was that? Store and forward flag. Okay, this flag indicates whether the trip record was held in a vehicle memory before sending it to the vendor. Okay, so it tracks if the record was stored directly on the server or in the vehicle's memory first, which is probably something that neither the driver or the passenger were aware of. So the chances of it affecting the tip in the end of the trip are probably 0 to none. So with this column, let's just get rid of it. You have my blessing. But when it comes to the rate code ID, we need to investigate further. So what happens is that there's usually a bunch of links on the dataset itself. Okay, source link. Let's try this one. Okay, we have data, dictionaries, and metadata. Great, and among them, we have the yellow trips data dictionary. Let's click it, and this is probably what we're looking for. There you go, rate code ID. Okay, we see a list of rate codes, and we can choose one of them. Now, in our case, since there is a rate code for unknown, which is our exact situation, let's go ahead and fill all the missing values in this rate code ID column with 99. So back in our notebook, we will go ahead and copy the rate code ID column name, and we will then select it, and we will call the fill_NA method on it, passing the number of 99. Then we will store it back to rate code ID, and perfect. We are only left with a store and forward flag, which we will now copy. And we will drop this entire column from our dataset. Okay, so let's type data.drop, and we will pass it a list of columns. In our case, that would be a list with a single column of store and forward flag. Then we will assign it back to data. Okie dokie, let's give it a run. And then finally, if we rerun our missing value cell for the very last time, hopefully, then we see that there are no missing values left. Yay! Next, we will move on with machine learning, splitting our data into test samples and training samples. Now, the first thing we do here is we usually shuffle our data and give it a nice mix. For this, we will type data.sample, and we will pass it the frac parameter, as in fraction, and we will set it to 1. So what it means that the sample method will return 100% of our data just in a random order. If we set it to 0.5, then it will return 50% of our data, and so on and so on. Since we're interested in the whole thing, we'll just revert it to 1. Now, another thing we do in professional settings is we don't just randomly shuffle our data. We want to recreate the exact same workflow time and time again. So what we usually do is we shuffle our data based on a seed number. So for example, if both you and I set our random_state parameter to the exact same integer, in my case 432, then my data and your data will be shuffled in the exact same order. Great. And now the last thing we need to do is we will call the reset index method, and we will pass it the drop parameter of true, which means that we're getting rid of the old index, the one we had before we shuffled, and we replace it with the new index that we have after shuffling. And then finally, actually, the most important part is reassigning this expression back to data. Otherwise, it will not be stored in place, okay? So this is very important. And great, we are done with the shuffling. Now, the next thing we need to do is we need to split our data into targets and features, where targets is basically what we're trying to predict. So in our case, targets equals data in the column of tip amount. And then features represent everything else. So in our case, features is all our columns minus the tip amount. We do so with data.drop, and we will pass it the columns of tip amount. Perfect. But that's not all, because now we need to split our targets and features into training targets and features and testing targets and features. And a common way of doing so is using slicing. So for example, let's split our features into features train and into features test. And in fact, if we want to do it professionally, we will usually call features X, and respectively, we will call targets Y. And then usually we will take most of our data and we will set it as our training data, our learning material. In our case, we can set xtrain to features.I location, and we will select all our data except the last 1 million rows. So about 37 millions of our samples are now training samples. And then we will take the remaining 1 million samples and we will set them as testing samples. We can do it by moving this colon from the beginning to the very end. And boom, we just split our features in two. And since this is how we split our features, we will do the same to our targets. Okay, because features, it's like questions, and targets is like answers to these questions. It's a very simplistic way of thinking of it, but it works, okay? So everywhere we see X, we now replace it with Y, and then everywhere we see features, we now replace it with targets. And beautiful, our splitting is complete. Now the last thing we'll do is we will print the length of our training samples and features, and we'll make sure that everything works out, that we had no errors and typos. So let's print the length of X test. Let's print the length of Y test, and we will do the same for our training subset, printing it right next to it. Sorry if my head blocks some of it. Let's give it a quick run. Beautiful, we have 1 million samples for testing and we have 37 million samples for training. We can officially proceed with the next steps. To perform training from XGBoost, we will import the XGB regressor. And this is our super fast machine learning model. Then we will go ahead and initialize it below, setting our model to our XGB regressor class. And into it, we will pass the device of CUDA, which means that our training will now run on GPU. So we expect it to be up to 15 times faster than our CPU. I can't really compare it with the full dataset because it doesn't even load on my CPU. But if we compare it with the smaller dataset, the one with the 5 million rows, we are looking at a speed up of 9 times faster on GPU. And actually, speaking of GPU, I'm not really supposed to share it yet. But since it's the middle of the video and some people are probably gone, I'm gonna give you a quick heads up. I'm actually about to give away an RTX 4080 Super, and it will be delivered to you straight from NVIDIA's head office. So unlike the previous giveaway when I sent it from my house, we will do it directly with NVIDIA, and that way, we can ship to a few more locations than before. And I'll be announcing it right before I leave to GTC DC. So in the end of the month, I'm traveling to Washington for this really cool convention. And then I highly recommend to stay tuned, especially if you live in North America or the EU. Because the last time we did this giveaway, I think only about 100 people participated. So your chances to win are pretty high. And now back in our video, it's a fast transition. Once we have a model, we will need to train it. For this, we will type model.fit, and we will pass it our X train and our Y train, the features and the targets of our learning material. And then once the training is complete, we need to move on with testing. For this, we will type model.predict, and this time we will only pass it our X test features. And then during testing, our model will try to guess the target for each of these features. So it will return us a list of predictions, okay, and we can then print them below. So we are basically passing it the exam questions, and then our model returns the answer sheet of the exam. Okay, let's see how it looks like. Let's quickly run this cell, and oh no, we get an error. So let's see what's going on here. Let's scroll down. And okay, we see that there's some issues with the data types of our columns, specifically the TPAP pickup date and the drop-off date, which kind of makes sense because our dates are probably stored as strings inside the dataset. So not numbers, but words. And if our machine learning model is a mathematical formula, and instead of passing it a bunch of numbers, we are passing it a bunch of words, then obviously there's going to be some issues. So for now, because we are so close to finish our training, let's just quickly copy these column names and let's temporarily put them aside, okay? We will get back to it shortly, but for now, let's just quickly breeze through it, okay? So let's see where we can get rid of them. Okay, we can do so in our features. So when we are dropping our targets column from the rest of the features, we can also drop these two new columns that we just copied. So let's paste them in a comment. Let's copy the first column name and let's add it next to the tip amount, and same goes for the second column name. There you go. Let's quickly get rid of this comment and let's rearrange our column names in a few lines like so. Beautiful. So now if we rerun this cell and we will perform training once again, okay, this time it should work. Let's do it. And beautiful. Once our training is complete, we will get 1 million tip amounts that our model guessed. So for each and every trip in our testing data, the model will make a guess of the tip amount that the driver should get. So for the first trip, the model thinks that the driver deserves $0.24 of a tip. And for the second trip, the model thinks that it would be more like 2.79. And then so on, a million times more. So now let's take all these guesses from our model and let's compare them with the actual values from the dataset. It will tell us just how smart our model is. Now, in order to compare our predictions with their actual targets, we will use an evaluation metric called mean squared error. And it is very common to use with the types of problems that we're trying to solve, as in regression problems. And in our case, we'll just borrow it from another module named scikit-learn. We talked about it in previous lessons, and if we installed everything through Rapids, then you already have it installed in your environment. We can just move on with importing it. So we will do so with from sklearn.metrics, we will import the mean squared error, hopefully with no typos. Then we will go ahead and copy the class name and we will initialize it below, setting it to the initials of MSE, like so. And now the first value that our class takes in would be the actual tip from the dataset. In our case, y test. And of course, the second value that it takes in is our predictions, or the tip amount that our model guessed. And then at the very end, let's print our MSE right over here and let's give it a run. And okay, our MSE is 1.24. Which means that the typical error of our model is $1.25 per trip. Okay, so if the model predicted that the tip amount is $2.50, then the actual tip is either $1.25 or $3.75. So let's see if we can improve this score by further cleaning our data. So before we even look at the dates, let's see if we can find some anomalies or some weird stuff in our data. And since 38 million rows is a bit too much to scan with our eyes, let's go ahead and create a nice summary. For this, we will select all the numeric columns with data.select_dtypes, and we will include data in the type of number. And then once we select it, we can go ahead and call the AGG method on it, as in aggregate, printing the minimum as well as the maximum and the mean or the average for each of our columns. Now let's give it a quick run. And actually, I prefer this type of data flipped. So let's also add a .T, as in transpose, to the end of our expression. And if we now rerun this cell, then our columns are way more convenient to look at. We have a minimum, a maximum, and a mean. And then we have a list of columns, so we can double check what makes sense and what doesn't. Now, if at this stage your kernel crashes, or if at any stage your XGBoost is out of memory, then it doesn't mean that you're actually out of memory. It just means that you're not managing it properly. In fact, we're not managing it at all. So let's tackle this. So at the very beginning of our notebook, we will create a new cell, okay, right above our cuDF pandas imports. And in this cell, we will import a module named RMM, as in Rapids Memory Manager. And this manager will allow us to reserve half of our VRAM towards cuDF pandas, and then the other half will be available for anything else. And the way to do so is typing rmm.reinitialize. Okay, hopefully I spelled it right. And inside it, we will specify a pool allocator to true, as in memory pool. And then we will set the initial pool size to a string of 16 gigabytes in my case, which is basically half of the VRAM that I have on my card. Okay, so now if we run this cell, we can then continue running our entire notebook cell by cell with no issues. So the first thing that doesn't make sense is all those negative amounts. I mean, what is this? This data suggests that instead of paying to the driver, for his service, the passenger ends up charging the driver. So this is obviously wrong. We cannot have any negative amounts. How do we explain it? Well, usually it means that there's a bunch of refunds. And if we look at the original dataset, before we shuffled it, we can see two transactions that look almost the same. It's just that one of them has positive amounts and the other one has negative amounts. And this is how we know that refunds are actually involved. So in that case, I'm just going to get rid of the refund and I'm going to keep the original charge. So basically, every single row where we can find negative values, okay, and mind you, these negative values are only happening when there's a certain amount or a certain charge involved, okay, so we can safely get rid of them. So if a row has any negative values, then we just drop it, okay, so this is number one. Anomaly number two that we're also noticing here is a trip distance of 350,000 miles. Okay, why is it weird? Because that's about 14 times the size of the Earth. And then in contrast, we have a trip distance of 0 miles, which is basically not a trip at all. This is in fact parking. So let's quickly tackle it in the cell below. For this, we'll type data and we will only keep the rows where the trip distance is greater than, let's say, half a mile. Otherwise, the trip is not very meaningful. And then we will store it back as data. And then we will do the same for the maximum trip distance. So let's quickly copy it. And we will only keep the rows where the trip distance is smaller than 100 miles. So let's say the distance to Philadelphia or somewhere out of the city. Great. And then finally, we need to take care of the negative values. Now, the command to do so is so ugly and unintuitive that we're not even going to type it. We will just copy it. Okay, so in your case, copy it from the description. In my case, I will copy it from the lesson plan. And then we'll paste it in our notebook, and I will of course explain it. So first, we select all the numeric values, just like we've done before. And then we will call the less than 0 method on it. And if any of the values in our row is in fact negative, then we would like to get rid of this row altogether. So this wavy symbol is actually a not operator. So we are only keeping the rows of our data where no negative numbers were detected. And please, if you have a better solution for this ugliness, please comment it below, because this is the only thing I know. And as you can see, I don't like it. Okay, I use it, but I don't like it. So now let's give this cell a quick run. And then right above, we will try our aggregation once again. Let's give it a rerun. And okay, our trip distance looks much, much better. And even though we fixed it, we see immediately another anomaly in the total amount, where the minimum is a total amount of 0, which is very weird because the base fare of our cab before the meter even starts is $3. And then for each half a mile, that's about 70 cents. So if our minimum trip distance is 0.5 mile, then our minimum charge should be $3.70. On the other hand of the equation, we have the maximum total amount. And why is it weird? Well, because the average total amount is $30 and the maximum one is like $386,000. And I have never heard of a 100 miles taxi trip that costs so much. This is just insane. So once again, just like with our trip distance, we are dealing with an entry error. Somebody who entered the data made some kind of a mistake. And it is of course up to us, professional data scientists, to fix it. So let's quickly tackle it. And for this, we will just copy these two lines of code from our previous cell and let's paste them in the cell below. Now we will replace our trip distance with the total amount, and we will then revise the minimums and the maximums. So the minimum is of course $3.70, but the maximum, based on 100 miles, if we are being extra generous, let's say that it cannot exceed the total amount of $1,000. Let's say somebody leaves like a very large tip. And now if we run this new cell and we go back to our aggregation, and beautiful, our total amount looks much, much better. And if we ever need to, we can keep slicing off more and more rows from our dataset. And speaking of slicing, let's actually make sure that we didn't slice off too much. So let's check the length of our data, how many rows we have. Okay, we still have 35.5 million rows, even though we've been dropping them pretty much in bulk. So let's say we are happy with the data modifications and we are looking to do another training run. Now, since we have meddled with our data and now we have less samples than before, then we will also need to redo our training and test splits. We will need to shuffle our data and we will need to split it once again into 1 million test samples and into 34 million training samples. So let's run this cell again and let's verify that our subsets are in the correct length, which they are, and then we can proceed with training. Now in my case, I'm just gonna merge two of these cells into one. I don't need to see the predictions at all. I just need to see my MSE score. There you go, like so. Now let's see if we can improve our previous MSE score with our new training run. So let's go back to our training cell and let's give it a go. Oh, wow, we got an MSE of 0.79, which is almost a half from what we originally started from. So now our model is wrong by about 80 cents. So let's quickly move on to the best practices section, where I will show you techniques for this type of dataset. Now, one of the most important practices is plotting the results of our training. So for example, we can easily plot the importance of our features, or which feature affects the tip the most. And actually, this is the reason why we have gathered here today. So with XGBoost, we can just collect it directly from our model as soon as it's done training. And then if we plot it in a bar chart, we can see that the most meaningful feature that affects the tip the most is the total amount charged by the driver. Surprise, surprise. Another important practice is called Hyperparameter Tuning. So if so far we reduced our error by cleaning the data or extracting a bunch of features from it, then in professional workflows, we also train our model with different parameters time and time again. We experiment with as many variations as possible until we find the best one. I covered it in great detail in my recent scikit-learn tutorial. But here's a nice example that you can apply with XGBoost. Another best practice is extracting the dates, converting them from strings into numbers. And what we usually do is storing things like month or day or time as separate features. And we even extract information that we didn't have before. For example, the trip duration. Now, the last best practice we will see is called validation. So if testing is the final exam, then validation is a quiz that we give our model during training. We are trying to check if it trains on the data, if it learns it, or if it memorizes it. So instead of splitting our data in two, we are splitting it in three, reserving a whole bunch of samples for the validation process. Now, this is beyond the scope of this video, but if you're looking to see an interesting example in code, I've included it right over here. And again, find it in my best practices notebook. And thank you so much for watching. If you found this video helpful, please share it with the world. And don't forget to leave it a huge thumbs up and all kinds of comments. Now, if you'd like to see more videos of this kind, you can always subscribe to my channel and turn on the notification bell. I'll see you soon in an awesome tutorial. So in the meanwhile, bye-bye.